example 4 on page 527. Add or subtract, simplify by collecting like radical terms if possible. So same question, just different terms or expression. We're given here 3 times cube root of 8 minus 5 times cube root of 2. Now, we have these two terms given that involve with the radicals. Before we want to combine the two terms with the radicals, we need to check if the radicals have the same index, k root, or and same radicals. So to combine the two radicals, those two radicals must satisfy these two conditions. If not, you cannot simplify it. So this is square root, right? This is square root. That's good. Same index, which is k equal 2. How about radicands? This term has radicand 8. This term has radicand 2. So the radicands don't match. So these two terms cannot be combined as of now. Now, you notice that 8 is not a prime yet. So that means you still can factor out, and sometimes you still can simplify. Okay? For this term, for this radicand 2 is a prime number, so you cannot factor any further. So you leave this as is. Your hope is that if this 8 radicands right here, if you can factor out its factors in a sense that you can simplify and obtain the radical 2 or radicand 2 right here, that means you can simplify, you can combine these two radicals, okay, and simplify. Okay, let's try. So we have 3 times cube root of 8 that's given. Subtract 5 times square root of 2. Okay. Now, you learned this before. 8 can be factored to 2 to the third power minus 5 square root of 2. Now, this square root has a 2 right here. Okay, k equal 2. It's not written, but we understood as 2 here. That means you want to obtain the factor inside this square root with the power of 2. If you have power of 2, you can move that factor outside the square root. Now, if you notice that this 2 has exponent 3, which is larger than 2, that means you can rewriting this term as 2 squared times 2, right? Because 2 squared times 2 is 2 to the third power. Since 3 is larger than 2, rewriting this to get 2 squared. If you have 2 squared with a square root with k equal 2 and they match, that means you can move this factor 2 outside the square root. Okay? We learned this before, earlier. Minus 5 square root of 2. Now this 2 has the exponent 2, and this is square root, k equal 2. That means you can bring the 2 outside. So 3 times 2. The remaining, this 2 does not have the power of 2, so it stays inside the square root, minus 5 square root of 2. You can simplify this to 3 times 2 is 6 square root of 2, minus 5 square root of 2. Alright, so we're all there. Notice that now we have 6 square root of 2 minus 5 square root of 2. So these two radicals have the same k root, right? K equal 2. So it's satisfied the first condition. And not only that, the radicands of this term is 2. The radicand of this term is 2. Satisfy this condition. That means you can combine the two radical terms. So to combine, treat the radical 2 as some variable, like x. So 5x minus, 6x minus 5x is 1x, which means, so I continue here, okay? So 6 radical 2 minus 5 radical 2 is 1 radical 2. Okay? Again, 6 minus 5 is 1. And don't forget the square root 2. That's why the answer is 1 square root of 2. 1 times square root of 2 is square root of 2. So to simplify these two terms, make sure you check these two conditions. If not, look for the radicands. Since it's not prime, try to factor out and obtain the square root of 2 if you have that, you can combine, like here, after you simplify this first term, you get this 6 square root of 2. Now they have same radicands. Then you can combine the coefficients 6 and 5. So 6 minus 5 is 1, and with the square root is square root of 2 as the answer for example 4.